Hello everyone, this is Jimmy and welcome to episode 17 of Multiblock Madness, where today we will be setting up an applied energistics system. Right now I'm thinking about where I want it to go. Most of our base expansion I think is going to be that way going forward as we expand our, basically as we expand this line forward and, left and right. So I'm thinking we'll put our applied energistics system maybe right over there. We can put the center of it over here and then yeah, I like that. All right, given that, let me show you what I've done between episodes. I've did a little bit of crafting, perhaps a little bit more than a little bit, but I've built a bunch of the components it takes to get our applied energistics system started. Most of these have vanilla recipes, so they're not that bad, like the cables, the crafting stuff. I do want to show off some of the really interesting recipes that, I just did. The crafting component recipes have your choice of plates to use. And the higher tier plate you use, the more yield you get. For this, I use the Manulin plate recipe because I have a lot of Manulin. The tungsten carbide one gives more yield, but I have 0 pieces of tungsten carbide. So this is a cool mechanic. I like that. And a lot of these components for auto crafting are very expensive. So if we look at, say, interfaces and molecular assemblers, there's a reason I only have 2 and 6 of these. Interfaces require one of these processor circuit boards each. It's 160 seconds to make, which is why I've only made a couple. And even then, this circuit board, okay, this step is 8 seconds, but this step is 80 seconds, and this step is 40 seconds. So our crafting right now and all of our Tech Reborn stuff is crazy slow. So I only have a few interfaces. Now there's this really cool mechanic, once again here, where by upgrading the plates used to craft from aluminum to scale, we get double the yield. You get extra interface per, and this scale plate is actually, at a glance, it doesn't look that bad. It's scandium aluminum, and it's 98% aluminum. That means by mixing in 2% scandium, you get an extra, you double your yield, right? That seems like a great plan, except scandium is not easy to produce. So to make scandium, we have to do a whole bunch of rock counting stuff. You have to basically go through the entire mineral sizer thing. So you start with uninspected minerals, you size it, you leach it, you extract it, and then you might get some. So instead of going through that, I just bit the bullet and crafted it with the plain-old aluminum plates, because we'll deal with rock counting later. When it comes to cabling, we'll use a mix of the Ender Owl cables and the regular cables. And if you look at the tooltip, it also says I've installed Trousers editions of Applied Energistics. That just has various quality of life updates, bug fixes, stuff like that. No gameplay features. Well, there's one gameplay feature in the update, or in Trousers Edition, some changes to blocking mode, but I have that turned off. So it should be completely compatible with a regular Applied Energistics when I give you the world download at the end, or if you're playing along for whatever reason and you're playing on a server and can't do the update, all you'll be missing are some really cool quality of life updates that we'll talk about when we get there. Anyways, let's take this box of stuff. Oh wow, this dolly's great. It doesn't even slow us down. And set it up right over here. I'm going to lay out my network as I usually do, using P2P tunnels all over the place to make it such that channels, for all practical intents and purposes, don't exist. So my main controller will consist of, right now, 4 blocks, but I have it set up to be trivially expandable up to 8 by just adding 4 more in these open spaces here. Each face of the controller gives us 32 channels. So if we connect a P2P tunnel to there, it effectively compresses that down to 1 channel. And then all that goes into a second controller, which acts as the controller for the subnet. My preferred way of laying things out. It's very intuitive to me. And when we have to link stuff, all we have to do is, well, so you get 32 faces per side of the controller, right? So the subnet controller has all 32 channels out of this face here will be connected to our main controller, and then all the faces everywhere else. In fact, this one should not be connected. You can make them not connect when they're adjacent with a cable anchor. Let me fix that real quick. It won't cause any problem for now because I have plenty of channels to go around, but sometime down the line that could cause issues. So anyways, put a cable anchor there, reconnect that, and now they don't connect. So all 32 channels out of this side face are for the main net. The channels elsewhere are for sorry, 32 channels out of this face are for the controller. Channels everywhere else are for P2P tunnels throughout the base. So anyways, all you have to do is link them, shift right click on the one on your main controller, and then right click on this and link them. They are directional, so it's input side to output side. Technically, one input can link to multiple outputs, although I, generally speaking, never do that. It makes it more difficult to track down when you run out of channels in a spot. So now, like, because I have a piece of dense cable coming off of this P2P tunnel, I can just look at this and say, yep, I have 7 channels in use. Whereas if I link this tunnel to multiples, then, you know, I have 7 channels here, but if the other link is using 26, one device will get dropped because 7 plus 26 is 33, right? But this one will say 7 of 32 channels. That one will say 26 of 32 channels, or whatever math is. And it'll appear like they should both be working, even though I've overloaded the network. All right. Anyways, with that, we now have our terminals. We don't have items in here yet, though. So let's come up with our item storage. I made 2 ME drives. Plan is to do something vaguely like this, where we can dash our drives here. And for now, I have 20 of the 16K cells. So this will be our storage for bulk items. Anything we have quite a bit of. Each cell holds up to 63 types. A type is a unique item. So it doesn't... Hold on, let me take this off of auto mode. But I stopped typing into it. My preferred modes, by the way, are sort by number of items. Set this to JRI synchronize standard keep. So that means the search box here, synchronize with JRI. Standard means it's not auto, so when I open the UI, the field is not focused, whereas in auto, the search bar is auto-focused. And keep means if I type something, leave, and come back, it keeps it. All right, so anyways, back to item storage. For bulk item storage, we use these cells. Each one holds 16,000 some bytes. Each item uses 1/8 of a byte, so effectively a bit. So if they all have, if you put all of one item in here, this cell holds 16,384 times 8 items. But each type you uses up some of the bytes. If you use all 63 types in a drive, it uses up 50% of its bytes. Some complicated math here, but basically each type is 50 over 63% of the drive's bytes used up. And then each unique item is a type. So it doesn't matter about stack size. Like technically the stack size for this pickaxe is 1, right? But if I happen to have a second pickaxe like this one that had exactly the same stats, perhaps we duped it somehow, they would count as 1 type. So generally speaking though, what I'll be doing for item storage of non-stackable items, that is items that tend to have different types, like items that tend to spam up your types but not use up your bytes, is to store them into junk storage units. These things hold something like 500 items, 250 items, 256 items, wait, no, 270 unique types effectively. So their junk storage units are very efficient at storing things that the ME drives are inefficient at storing. So let's go grab these and link them up to our network, and then we can do the big ol' item transfer. Generally speaking, when it comes to where I want my items to go, I want them to hit specialized storages before they hit the generic storage. So stuff like these drives, or these junk storage units, I want on higher priority, set them to 2. And then anything that's stored into a drive network later, or a drawer network later, we'll want that to be like priority 1. And then anything that goes into these drives, I want the lowest priority. So we'll set that priority -1. So anyways, now if I were to insert items, say let's take my laser gun. We put it away, it would have gone into one of these somewhere. Kind of hard to tell exactly. Oh, there it is. Because it's able to go into the junk storage unit, so it puts it in there. Whereas if I put, say, my cable anchors away, these cannot be stored in trunk storage, so they get stored into one of the drives. Cool. Now with that, I think we're ready for the big transfer. Let's grab a chest, maybe. You know what? Let's set up our wireless first. What am I saying? So there's a wireless terminal for Applied Energistics as well. To use it, we have to link it to the network through the security terminal. So just drop it in this slot. It's linked. And now we can wirelessly access our network. We need an access point to serve as like the, your Wi-Fi router. It uses energy dependent on how big the range is, and the range is dependent on how many wireless boosters you put up. 500 RF tick, sure, that's cheap. For 232 meters of radius, that's kind of huge. In fact, that's probably more than my flight area. So anywhere I have flight, I definitely have wireless access. If you need wireless access beyond that, say interdimensionally, you can put these infinity boosters into this slot. Each one gives what I put in 32, right? So each one gives 100 units of infinity energy, and each point of infinity energy lasts 1 tick when out of range. So turn auto consume on as well. That means that each point of infinity energy, or each card, gives you 5 seconds of out of range Wi-Fi usage. It's not a lot, but it's something. Anyways, let's set. Come on. This button, there's like an item behind it, so I'm trying to there we go. Click it without clicking the item. So yeah, with this, we can now access our wireless network, or our Applied Energistics network, from anywhere. That noodle is growing. Another really cool thing that the wireless crafting terminal gives us is access to the magnet card. So craft it, shift right click it once to turn it on, otherwise it won't work. Place it into the magnet card slot, and then you can turn it on in the future by clicking this button. What this does is that it functions as a magnet. Any items that it picks up. What mode? Oh, I have it set to game. Come on, there we go. I have it set to extra items are added to inventory mode, and it's currently on an empty whitelist. So if you wanted to just pick up everything directly into the Applied Energistics system, set it to an empty blacklist, and ta-da! Any items nearby automatically get sucked directly into the Applied Energistics system. Why is that useful? Because I want to transfer all of our item storage out of simple storage into Applied Energistics. So it's as easy as, with our magnet on, make sure it's active, empty blacklist. Why did this item go into my... Yeah, hello? Why are items going into my inventory? Maybe an empty blacklist doesn't work? Let's try something. We will blacklist that specific item. Now will items get automatic? No, what's wrong with my magnet card? Hello? Why isn't my magnet card magneting? Oh, I know. I put a demagnetizer here and its range is just set way too high. So it's I've put this here so I can drop items onto the belt directly, but then it's in range of that, and apparently that demagnetizer is able to turn off my magnet, which makes sense. It is a demagnetizer. The demagnetizer beats magnets. So now, with that fixed, should be break chest, items go straight into Applied Energistics. And we just do that. Do I dare raid mine the chest? What could go wrong, right? Yeah, all the items just go directly into Applied Energistics. So I can... Vein mining in your base is scary. Unfortunately, that strategy doesn't work on crates, because crates keep their inventory broken. And just like that, all of our items are in the ME system. So here we go. Now, this still doesn't link up to our farm, because that's a little far away. I mean, it's probably like 400 or 500 blocks. Probably not even that far, like 200-300. I could run a cable over there, but I'm hoping that we can get access to a reasonable wireless solution soon. If not, I'll bite the bullet and run the cable. Anyways, with that, let's look at how full our drives are. Oh wow, that took up a lot more of our drives than I thought. I was expecting more of it to go into junk storage, but apparently not. I mean, there's definitely a lot of stuff in junk storage. The fact that these drives are just over half full while having most of their type used up means that I'm not very efficiently filling them. They are negative priority, yeah. Dang, okay. Well, I might need more drives sooner rather than later. Next, let's set up our auto crafting. So that's done using, well, let's set up the crafting CPUs first. Let's turn off magnet mode so I can actually break blocks. The crafting CPUs are what actually hold your items during the crafting task. For this, I typically only need a couple crafting CPUs because I don't do that much. I only, generally speaking, only use these for on-demand crafting, and I don't do all of that much on-demand crafting nowadays. So let's start with 2. The size of the crafting storage just determines how big an auto crafting task you can do. The number of co-processors you have assists with sending more items out as you craft. So why does this not connect? Weird. All right, it doesn't really matter. You only need one connection to each crafting unit. But anyways, that's our crafting CPUs. Next, to actually do the crafting, we're going to have molecular assemblers for that. So what's more expensive right now? The interface? Let's see. So interface uses a board. That's about the only expensive part. That's not true. The quartz glass is annoying too. The assembler uses the same. Okay, so it's basically the exact same recipe, except it swaps the board out for a crafter. And I think the crafter is more of a pain in the butt than the board. So I'm going to make a couple more interfaces, and then we'll set them up such that we have a... let me start by making more interfaces. 2 is not enough to do anything. Ain't that cold? Go away. Die. Alright, well, we killed that before it did much damage. That's good. Soon, we will get proper solutions to deal with them. I mean, we already have we have access to the Thaumcraft solution. I'm just stubborn. I don't want to do it. So we're going to keep waiting. That taken care of, back to our assembler tree. So I want to maximize our ratio of interfaces to assemblers because assemblers cost slightly more. Additionally, this assembler tree is actually a temporary thing in this pack. Eventually we get access to Lazy AE2, which has the mass assembler in it, which serves as a much more efficient and fast molecular assembler block. So I no longer need to do this whole like ME interface molecular assembler thing, which means this is only temporary, which means it doesn't have to be like the most efficient, fastest thing ever. However, we can't make our mass assemblers for a bit. We need tungsten steel, and I guess we can make this chassis already, but primarily we need tungsten steel and some other stuff. So until we get there, we'll have to use this. Anyways, I'm going to set this up then with interfaces sharing assemblers wherever possible. Something like this. Now, this, strictly speaking, is not like the most efficient. We could, you know, they're basically each assembler can, or each molecular assembler can support up to 6 interfaces. Well, I guess, yeah, it can do 6 because they transmit channels through it. But this way, you know, they only do 2, but it's a bit easier to expand and not worry about channels. So this gives us 12 interfaces worth of crafting patterns. Each one holds 9. Hopefully that's enough, because the other thing we run into is that for now patterns are also kind of a pain in the butt to make. They require this basic logic chip, which, well, actually the logic chip isn't that bad. These foils are a little annoying because for now I have to make them in the profiling bench, which is manual. At least as far as I know, there's no way to automate the profiling bench. And they take 2 quartz glass each, which again goes in the arc furnace, takes 25 seconds a pop, which is a fair chunk of time, but whatever. I have a stack of patterns to get us started. So now we should be able to do auto crafting just as a test recipe. Let's start with I don't know, the old chest. So right off the bat, here's a feature of Trousers Edition Applied Energy 6. It can handle ghost items, so you don't need to have a literal item to drag it in. Anyways, we'll import the chest recipe, but I don't want that wood. I think for now I want to craft chests using this wood, because that's what I have the most of. Encode that, drop that off in... Oops, I forgot to link my... you'll notice I forget to plug things in a lot. I didn't link IPTP tunnel here, which is why we don't see those interfaces yet. They're not actually part of the network. But once it decides to load in, there we go. We see our molecular assemblers. We can drop the recipe in one of these slots. I thought that icon switches to show that up a chest. Apparently not. So here's some of the new features of Trousers Edition applied to logistics. There's a Find My Interface button. Highlight it for you. Excellent. Not so useful on your assembler tree, more useful when you have interfaces connected to machines and you're like, you know, where on God's green earth is my interface connected to my assembly machine number 36? Well, highlight my interface to find it. The search here is similar to vanilla applied logistics. You can search outputs, but there's a new search bar here that lets you search by inputs. So if I want to find everything that uses wood, I can do that. Cool. This button shows interfaces with free slots only, that is molecular assembler, or interfaces connected to molecular assemblers that have free slots only. It's just a nice filter. And this hides all interfaces that are full. Also just a nice little filter to declutter your interface terminal. Moving on, I want to connect some of our external storages to the ME system. So the biggest one is our wood drawer that's connected to all of our bonsai pots. That is hooked up via storage bus. We'll set it to priority 1. And now we should see that we have a whole lot of dark wood. Well, all our wood stuff is now accessible. The other drawer I want to hook up is our farm. And I took a little bit of looking at our wireless options. Not looking good. So there's the standard wireless from built-in apply. Well, there's a wireless connector from AU2 stuff. We can make this. However, this thing for the distance we need to cover will ask me for like 100,000 RF. I don't have 100,000 RF to give it, and even if I did, I wouldn't use it for this. So the other option is to use the quantum system from applied logistics. However, for this we need singularities, and singularities are, and other stuff. Like I'm not even gonna dream about doing this yet, which only leaves actually wiring it up. However, we don't actually have to run ME cable all the way over there. In fact, running ME cable all the way over there is going to be a little, you know, it's a lot of cables. We're going to do something slightly different and perhaps a little bit cheeky. I like cheeky. By abusing item laser relays, we can effectively access that inventory from anywhere. So with range upgrades on our item lasers, they have 35 block range, and that is just over 2 chunks. I think we're gonna go 1 chunk, 2 chunk, and I don't know, we'll just hop over the water like this, I guess. Hook it all up, and any item interface connected to these lasers gets to see every every inventory. Oh, too far away. Gets to see every inventory that's connected. Wirelessly over not technically any distance, you know, it's not an infinite distance, but it is you get to cover 35 blocks per relay as opposed to needing, you know, 35 cables to cover it. And this way we can, instead of using, you know, the 200-ish cables, we use like 6 item lasers. Plug it in, set this priority to +1, because this item interface now, because it's connected to the drawer, for all practical intents and purposes, is a proxy for that drawer. It's a little bit too far away for us to have historically done it with a phantom face, so the lasers will have to suffice. But yeah, now when we look into our ME system, all of our items, ingots, you know, blocks, whatever, go up here. So now I no longer have to fly over there, grab a couple stacks of items, store it into our ME system to use them, etc., etc. So next thing I want to do is teach our autocrafting to autocraft the components to make, you know, more of the ME system, right? The cables, the interfaces, etc., etc. That's generally speaking just going to be a lot of recipes, so I'll probably not show much of it, but I think I have enough. Well, I definitely have enough molecular assembler slots to hold it all. I'm about 24 recipes in, and I realized that with the exception of the 24-ish recipes we see in here, we haven't actually made any progress today. There's nothing our ME system can do that our simple storage system couldn't do. So let's try to get around to doing some progression today. What I first want to do is set up a few more drives so that we can actually hold a few more items. And for this set of drives, I'm going to use 64Ks. Not really, because, oh, just kidding. We're not going to use 64Ks. We're going to use 16Ks because I can't afford that many 64Ks. I was about to say, we don't really need the larger storage disks yet, but if we could make them, we may as well. All right, well, these are cheaper, and because our drives are all orange, that means that, right, they're out of types, not bytes. And, like, none of them are even close to out of bytes. So we don't... They're, I'm storing more small quantities of items than large. All right, anyways, progression. I would like to make one very specific thing today, and that is the Overclocker upgrade. So in order to make that, we have to get into thermal. Thankfully, we're right there. We can just make the machine frames already. There's a recipe that makes double, but I assume there's something... Yeah, we have to use scale again. Oh, I wish I had access to scale, alas. Because we don't, we have to use the inefficient machine frame recipe, and that requires hardened glass. And specifically, it has to be thermal hardened glass, which I don't think there's an easy way for now for us to convert between the two. We can't make this, can we? Tungsten? If I get some tungsten, and this can be looted in the end, what should I have to get? A block? Let's just do it the, basically, in order to get thermal hardened glass, we have to use this recipe for now, which is a bit of a pain in the butt. But once we get an induction smelter, we can make it in the thermal machine. So, yeah, I guess I'll suck it up and just make... Oh, this is even less efficient than the induction smelter. Induction smelter makes 2, alloy smelter makes 1. All right, given that, then, yeah, we'll make our first batch by hand, and after that, we'll make the induction smelter as one of our first thermal machines. For no good reason, I'm really fixated on this plan of making easier glass, hardened glass. So I noticed that fortified glass has the exact same or dictionary names, which generally means there exists a way to convert between them. The fused quartz has different or dictionary names, so I didn't expect that we would be able to do that. Anyways, chisel can't do it. The forged lexicon does not appear to be able to do it. So last chance is, can the drawer with the conversion upgrade do it? Nope. All right, you win this time, game. No, I refuse to give up. The or dictionaryificator says it's used to translate between blocks using the or dictionary. I don't know. It doesn't use a mechanism frame, so we get to make one and test it out. I assume it doesn't use power. New filter. Compatible or dictionary key. I assume I want block glass hardened. Hey, where'd my item go? My offhand. Let me figure out how this block. Nope, this thing doesn't work either. It doesn't accept block glass hardened as a compatible or dictionary key. In fact, it doesn't seem to accept any blocks as or dictionary keys. Oops, ingot. Does it accept ingots? It does, but it accepts ingots and ores, I've discovered. And then you can convert between the various forms. But whatever. I'll suck it up and craft hardened glass the normal way. While I technically cannot fully autocraft machine frames right now, what I can do is set up the recipe as if, just to like get the ingredients together for me. And then when I hit the go button, it'll gather all the ingredients together in one place. So here it is for 1 set, 2 sets, and I think I ordered 4. So grab these in just a second. Fill up a capsule. And I believe that circuit is what we throw in there at the end. So it saves me the trouble of having to pull every ingredient individually out of Applied Energistics. Now, pretty soon we'll get the 3D printer, at which point we can just use that same recipe, except plug it directly into the 3D printer instead of into the, into a dummy chest. But this allows us to make our first few thermal frames. And I suspect the quest, I was about to say make one, get one, but no, it's make one, get a conversion kit. I'm okay with that. 1 induction smelter coming right up. We still have the upgrade kit we just got, so let's plan on putting 4 augments in it. I don't actually know how many augments we get in machines in this pack. This is a configurable value, so we should check. Nope, it's still 4. Cool. I had a moment to think there if I'm allowed to pick that up with a pickaxe. Turns out the answer is yes. This is the thermal machine. All right, let's set it up for automation. So, it should be pretty simple. Interface provides items. The machine does the crafting. Unlock the flux slot. This is both the input and output side. And that's it. Plug it in. This will plug in. Oops. Plug it in on bottom. Oh wow, this machine is fast. It uses up to 30,000 RF a tick. It has an internal buffer of 30 million RF. And if I just use it to do something simple, like make, say, bronze, doesn't make sense to use it to make bronze because I have copper and, well, I have bronze seeds. But, you know, just bear with me here. It makes it very fast. Yeah, but some of the other recipes some of the recipes use a lot of energy. Some of them use even less, like solarium here is made basically instantly. But point is, very, very high energy machine. Let's switch our hardened glass recipe over to it, and this is a chance, whoopsies, to show off a couple of the features in Prototype or Trousers Edition JEI. So, or Trousers Edition Applied Energy 6, sorry. When you import a recipe, say this one, it'll do two things. First of all, it'll automatically switch from pattern mode to processing mode. You no longer have to set the mode. I mean, there's only one right mode, right? If you're importing a crafting recipe, it's crafting mode. If you're importing a processing recipe, it's processing mode. So it does that for you automatically. Wow, magic. And it adds these buttons here, which increase the batch size of your craft for you. So if you have ingredients that use large quantities of or use often, it helps to have large craft size. It reduces the load or reduces the number of co-processors you need for the craft to be successful, or for the craft to be running at full speed. And it also reduces the, like, if you only need a couple in the future, you might just have them on hand. So by increasing the craft size, you make your crafting, generally speaking, a little bit easier. So with that, now let's request some hardened glass. How much energy does this take? 8,000 RF. This should be like 1 tick per then. 100. So request 100 hardened glass, and it's not quite 1 tick per. Oh, there must be a lot of efficiency losses from these augments. Does it tell me? It doesn't tell me how much exactly each reduces the efficiency of it, but oh well. But yeah, ultimately that was very quick, right? In a matter of seconds, we got our 100 plus pieces of hardened glass. So if thermal machines are going to be that fast in this pack, I foresee us using them a lot. Anyways, if we're going to get to overclockers though, I need a fluid transposer and maybe something else. What exactly was it that I needed to make the overclocker? All right, so I need the circuit. Yikes. They all make one. So I guess we'll use this cell. We have to fill water cells, which can be done in any of a 500 million different machines. And we have to fill them with gelid cryothium. All right. I was just looking at ways to melt down gelid cryothium, and it kind of caught my eye here. It's 8,000 RF to do it in a magma crucible. Like, okay, that's, 8,000, not bad. To do it in a melter, it's 4,000 RF per tick for 400 ticks. That is, in 2 ticks, you've spent your 8,000 already. The other 398 ticks, you're spending extra energy. It costs 200 times more energy to melt it in the melter than the magma crucible. Given that, we're just going to make a magma crucible. Don't strictly need it. Use an extra machine frame. Saves like 30 billion RF per item. Finally, I got a blizz to spawn. I really needed just one, but that was an ice wraith. And I also didn't swap it. Dang it! Alright, so apparently I did not get a blizz to spawn. I need one blizz to swap, and this is like my 3rd time trying to find one, and I keep failing. Time for plan B then. If I make some snowballs, or make some blizz powder from snowballs, we can turn 5 to 1 in a compactor, and then if I get 4 or some number of these, I can justify using my blizz seeds. Right, I technically don't have any crafting seeds left to make more, but I found blizz seeds earlier when we had agricraft things. So instead of making a mob farm for blizzes, we'll just add it to our seed farm. So I guess technically I need to make 8 blizz rods before I am legally allowed to use my seeds. I think it's 2 rods to a chunk, 4 chunks to a seed, so yeah. The compactor that we make for this is also relatively fast when it comes to making things like this and plates, so it'll be our go-to plate maker for now, ahead of the metal press. So it can do double duty. At last, our overclockers are ready to craft, all our infrastructure is in place, and it's all on autocraft. So all I have to do is hit the go button. These 4 data control circuits, by the way, can't look into that recipe from here, take it. Data control take literally forever to craft. So we can't do it by hand yet because we don't have stainless steel. We have to use this recipe 160 seconds, really, each in the assembly machine. That's almost 3 minutes, or that's 12 minutes of assembly time, almost, I guess, like 11, just to make the 4 of these. These, you have to make it double that amount because you have to do it again for that. The circuits, okay, these are instant, but like, this takes 80 seconds. My time, I think last time we looked at our time in a bottle, I had like 24 hours in it, right? All of that time just about has been dumped into this assembly machine doing this. Anyways, it is high time we made 4 of these to put in the assembly machine so that I can hook up at least a assembly machine to the ME system and make our crafting faster. So what's taking you so long? You are filling cells, which is here. You melt that. Oh, wait, this is the wrong color. There we go. And then I actually have to send the final item back somehow too, don't I? How do we do this? Output. Oopsies. You should be, wait, what? Input the right, output the back. There we go. I can work with that. And then just loop the item back into an interface. Any interface will do. Doesn't have to be the one it came out of. Our first 4 overclockers are done, and just look at how slow this is without it versus how broken the UI is with it. But I think it's faster with overclockers than it was fully timed and bottled. So and the 2 stack, of course. No reason, if I want them even faster, no reason I can't do this up until a point. At some point, I can't provide enough energy. But yeah, now our assembly machine steps no longer take 30,000 hours plus all my time in a bottle time to do. Let's wrap things up today by making a large batch of overclockers for all of our other machines. So each one takes 4, and there's really no reason not to put 4 in every single Tech Reborn machine. Maybe some of the blast furnaces use too much energy for it to realistically power with all 4, but generally speaking, you know, you should. Anyways, I moved our assembly machines out here because I figured we might want more than one. There's a lot of assembly stuff that has to be done, so trying to do it all in one kind of bottlenecks you a little bit. Is that even a valid recipe? That is. It is a little annoying for these machines. You have to configure their input-output on every single one. Like, there's no way to copy paste it, but I'll suck it out. All upgraded, and now the process of making these boards, which, remember, previously this was like 5 minutes per task, right? Now if I order 10 of them, I've intentionally taken all the advanced circuits out of the ME system. They're in my inventory, so you know they have to make it from scratch. But I expected, instead of taking 5 minutes to make the 10 or 5 minutes per, it'll take less than 5 minutes to make all 10. I probably didn't distribute my recipes in a very efficient way if they're not running in parallel either. Oh well, these machines, you know, they're just crafting their thing. I guess I could rearrange it such that both machines service both sets of recipes. That would probably be more intelligent. I'll do that later. But yeah, just like that, all 10 are done. So they took, what, 45 seconds to make 10 instead of 5 minutes per? That is the power of Tech Reborn Overclocker upgrades. Anyways, that's it for today. I hope you guys enjoyed this video. Hope to see you in the next one. Take care and bye-bye.